Today we will be discussing the problem from B.Math admission test 2011, the problem number 9. So this problem actually tells you to find the minimum value of a function x square plus y square subjected to a special constraint. So these particular problems can be solved using two methods. One is visual method, or you can simply say by converting it to one variable problem. And there is another method which is much more powerful than this one and which can be extended to higher dimension. It is called the Lagrange multiplier method. So in this video I will be showing you the first one, which most of you guys have used, and for the second one we will be seeing that in some later videos. So let's see how to solve this particular problem. So this surface is one of the most important thing for this particular problem. This particular surface is the representation of the equation z equals to x square plus y square. That is this equation. Now you have to find the minimum value for corresponding to this particular surface on a particular plane, on a constraint, that is on this particular plane. So this particular plane has the equation of the constraint, which is x plus y equals to 1. So this means you have to actually find the minimum value of the particular surface on this particular plane. So this is what do we mean by constraint. That means this particular problem boils down to the problem where you have to find the minimum value of a particular curve, that is this particular curve, which is the intersection of the surface and the plane. And as you can see, there is a particular minima for this particular curve, so I can just forget about those two surfaces and just consider this particular curve. So our problem is now a one variable problem. Now we can easily solve this particular problem using the idea of derivative. So let's see how to do that. So we have these two equations. Now what we have to do, we have to convert it to one equation, that is the equation of the intersection, that is the yellow curve, like I have shown you before. So we can find the value of the y from the second equation, that is the equation of the constraint, and then we can put the value of that particular y on the equation of z, that is our main equation. So putting it gives me this, and simplifying it a little bit, I will get the equation of the yellow curve, that is the equation of the common curve, that is this one. Now using the normal idea of finding the critical points, I can say that to find the critical point of the function, it must follow the condition that the derivative of z with respect to x must be equals to 0. So the x value must be equals to half. Now you have to do again another derivative to find the maximum or minima, but in this case it is very clear from the graph that it is actually a minima. So the minimum value of z is at the point x equals to half, and if I put this half in the equation of z, that is the one dimensional equation of z, that is 2x square minus 2x plus 1, then I can find that the minimum value of z is actually z equals to half, and this is our result. So you see how easy this is. In a later video we will see the second method. So this is all for today.